Welcome to our RhinoLands webinar, tailored specifically for new users like you. In this session, we'll guide you through the essential features and functionalities of RhinoLands, helping you get started on your journey with confidence. Let's dive in. RhinoLands is the professional BIM landscape architecture software that integrates with Rhino. I'll make you through its main features, but first, let's explore what RhinoLands is all about. This video has two parts. First, we'll overview the main features of the program, then we'll dive into the program interface and its functions by developing a landscape project. RhinoLands includes powerful tools for technical drawings, create precise and detailed 2D plans, 3D modeling to develop intricate 3D models of your landscape design, automatic listing feature which generate comprehensive lists and quantity takeoffs automatically, and visualization tools to enhance your projects with advanced visualization options including realistic renderings and shadow simulations. RhinoLands is a standalone independent software, meaning you don't need to install any other programs for drawing or modeling your landscape. It includes Rhino 8 and will stay updated with future versions of Rhino. RhinoLands is an invaluable tool for landscape design, infrastructure, architecture, and civil engineering, urban planning, and environmental projects. For example, you can easily model a forest using RhinoLands tools in just a few minutes. Let's see its core features. Well, first, it includes an extensive plant database in 3D, 2D with botanical information. The software provides filters to help you select species based on form, climate, soil type, water need, flowers, and other characteristics. As you see, there are different blocks for the same plant species that are going to be used in different displays and in different views. RhinoLands offers various display modes to suit your needs. In view mode, you can switch between wireframe, shaded, and rendered views. For plant-specific displays, you can toggle between conceptual, detailed, and realistic modes. The realistic mode includes a seasonal change option, allowing you to switch from spring to winter to visualize how the scene transforms over time. This allows you to create and compare seasonal changes within the same scene, offering valuable insights into how your landscape design evolves throughout the year. You can seamlessly switch between 2D and 3D modes. If you're more comfortable with 2D design, simply continue working in that mode. With a click of a button, you can switch to 3D mode to visualize how your design translates into 3 dimensions. Vegetable insertion offers multiple options. One is individual insertion, add plants one by one. Then paint mode, utilize a paint light tool to scatter plants randomly across the plot by moving the mouse. Block conversion, transform AutoCAD blocks or points into realistic 3D models within RhinoLands. Row or group insertion, insert rows of plants with a specified distance and plant combination, or group of plants with minimum distance or matrix arrangement. You can also add shrubs and ground covers by specifying the quantity per square meter or per linear meter. Within the plant database, there is an option to edit existing plant models and make modifications. Simply install the Plant Editor add-on to access this feature. A standard feature of RhinoLands is its robust terrain modeling tools. Terrains can be crafted from curves or point clouds. You can elevate contours and generate terrains effortlessly. Additionally, perform various land operations such as cuts, fills, passes, holes, or divisions, all of which can be easily edited using control points. The software also provides accurate reporting of volume and area measurements for these operations in quantity takeoffs. As you can see, This allows us to compare two or more scenarios for the same project. The quantity takeoff of land operations help us make better decisions. Another notable feature is dynamic 2D documentation. You can tag plants, add labels, and generate quantity takeoffs for species, urban furniture blocks, walls, zones, and other elements within the model. Additionally, you can include images of the species and produce 2D plans, sections, and elevations for the project. In this way, you produce different documentation of the same project model. The Hardscape tools in RhinoLands enable you to effortlessly create parametric walls, edging, paths, ramps, fences, and add furniture to your landscape design. RhinoLands includes tools for irrigation systems, allowing you to place sprinklers and draw a piping system with ease. The pipes and the sprinklers will be automatically listed for convenient reference. To visualize your project while you have a realistic 3D model, RhinoLands offers several tools, ranging from a walking experience where you use keyboards to move the cursor to rendering options. You can conduct virtual simulations of sun and shadow movement within the model, which is crucial for landscape design. By specifying the geographical zone and adjusting a slider, you can visualize how shadows move throughout the day and in different months of the year. This rendering of a landscape project was created using the internal Rhino render. So with RhinoLands, you can achieve similar realistic results even without external rendering tools. There are the rendering results of a RhinoLands model utilizing some of the most popular rendering tools in the market. These are the results with Enscape, V-Ray, Twinmotion, and Lumion. This animation is from a RhinoLands model rendered using Enscape. The plant featured are native RhinoLands species. So this is the way that you can see how you can bring your project into life. Another feature is the ability to implement parametric design in landscape architecture. In RhinoLands, Grasshopper covers as the parametric design tool applied in two workflows, generating geometry through algorithms or linking external data to existing BIM geometry. We'll explore examples of both approaches. These are the Grasshopper components of RhinoLands. As you see, you can link objects like terrain and plants to algorithms. It's important to note that this is an advanced level, and as a regular landscape designer, you do not need to learn Grasshopper to work with the program. However, let's explore the potential of Grasshopper. This video demonstrates an example. We place a group of plants with varying sizes. We have a Grasshopper script for creating plant edgings with the same diameter as each plant. As they are linked to the plants, moving the plants also moves the edging accordingly. And here is another use of Grasshopper, linking environmental data to a landscape model in RhinoLands and conducting environmental analysis. These are workflows that we have published and are available now. We can automatically calculate the carbon sequestration of plants after designing the project. Additionally, we calculate the cooling effect of plant shadows on the ground, conduct shadows on the floor, and access the amount of solar radiation absorbed by plants. On the left side, you see a landscape model, and on the right side, you see how the script will calculate carbon sequestration. For more information, check out our YouTube channel. RhinoLands is a BIM tool with a seamless workflow and interoperability with other programs through IFC import and export file, as well as through Rhino inside Revit technology. You can open a landscape model from RhinoLands in Revit and all its BIM objects can be recognized as such within Revit. The design process with RhinoLands is summarized in this short video. As you see, you can generate a range with lines and points, or import it by looking for its location on the map. Once the terrain is generated, you can modify it by using terrain operation tools like cut and fills and create paths, or add boundary to the terrain. Remember that all these operations will be calculated by the program at the end. You add hardscape objects like walls and fences or stairs to the project. In continue, you can insert urban furniture to the project. You can use it by inserting from our block library or inserting from any other file formats that are available and are compatible with the program, like for example, SketchUp files. In continue, you insert plants individually or in a row in different arrangements. Everything is parametric, so you can modify its arrangement or its size at any moment. So in continue, you can tag plants, add labels with their name, their quantity, add the image of plants by a specific tool, and produce different types of documentation, obtain the list of plants, walls, terrain, and so on. And at the end, you render the project by a rendering engine. You can see also the seasonal change of the project. And finally, you will have a realistic result of your idea. This is the workflow diagram of RhinoLands. You can perform all drawing and 3D tasks within RhinoLands. Additionally, if you have drawing files from other CAD programs like AutoCAD or models from SketchUp, you can open them directly in RhinoLands. Furthermore, if you have GIS files and LiDAR point clouds or similar geographical data, you can import them into RhinoLands. Collaboration is also possible with import and export files to Revit, 3D Max, and Archicad through the IFC file format. For visualization, you can render the model using compatible renderers like Enscape, V-Ray, Twinmotion, or Lumion. Alternatively, you can print the model using a 3D printer or view it using a virtual reality headset. Additionally, you can export your documentation to Excel or PDF formats, or simply create and print layouts directly from RhinoLens. In summary, all your design steps can be completed within RhinoLens program. You can generate various plans, layouts, and sections, as well as produce realistic renderings, all using RhinoLens. This is a real-world application of the program, showing a green infrastructure project in Madrid. All layouts and documentations were created using RhinoLens. Well, in summary, we offer a 60-day free trial of RhinoLens, allowing you to explore the software's capabilities firsthand. After the trial period, you have the option to purchase a permanent license or choose a subscription plan. Additionally, we provide free technical support to assist you with any questions or issues you may encounter. For educational institutions and laboratories, we offer licenses at reduced prices, making RhinoLands accessible for educational purposes. Well, let's start the second part, which is program interface and functionality demo.
Hello, everybody. So I'm going to show some of the features that we have seen in this presentation with this new interface of RhinoLands. Those of you that know Rhino will find this interface quite familiar because, as Helga has mentioned, it's a simplified interface, a user interface with the necessary commands to develop any landscape project. Those of you that have never seen Rhino, well, you can discover easily all the tools necessary to develop a project from 2D drawing tools. So if you are familiar also with 2D CAD tools like AutoCAD, you will find here all the necessary tools to draw in 2D. Here you will find all the tools to model in 3D, from working with primitives, surfaces, and all the commands to edit these surfaces and 3D objects. And then we can find all the necessary tools to generate terrains, either if we import them from the earth or from them or GIS files, or if we create them from points and curves and all the tools to do operations with them. Then we will find all the tools related to vegetation and the different ways we can insert these vegetal elements, and also the civil work objects. We can find some irrigation tools here, documentation tools for listing all the elements that we have in the project, or if we want to add dimensions and other text in the model. Okay. Also, we have here the option to work from page layouts, just like in AutoCAD, for example, and prepare our 2D drawings. Okay. Here we can find some visualization tools. Okay. Different options to arrange our viewports or to set different views from our each one of the viewports. Okay. Work with different display modes or shutter render. And finally, some selection tools that lets us select objects by type. Okay. If we take a look at the other toolbars here, we can find some quick access to zoom options, isolate or selection options. And if we take a look at the panel on the right side, we can find here the tools to, for example, see the different layers of our project, or we can switch to the properties panel to see the features of the objects that we select. Or here we will find the edit panel for all the objects and all the parametric features that we will see on the objects that we select. Okay, we'll see some of these features in a moment. In a usual situation, we may want to start from a DWG file that we got from a client or we have developed, and so I'm gonna just open it to see how it works. So it's as simple as select open, select a DWG file, and click open. We need to define here the import options. We can just select the default. And here you can see all the 2D drawings that come in this DWG file. If we explore here the layers, we can see that some objects are stored into these different layers. Okay, and if we select these objects, we'll see control points. We have this gumball to move the elements. So it's very easy to edit these objects, to navigate through the viewports. Just double click to expand it and work from a single viewport. And here on the left side, we can find transform commands such as copy, move, rotate, or scale, and other commands to work with the object that we select. But let's jump to this project, but a little bit more developed. Okay, so I'm gonna show it a little bit more advanced, so we can work with plants, terrains, and other stuff. Okay, but first of all, let's explore here the edit panel, because this is a very useful dialog from where we will be able to switch from the different display modes that the elements of RhinoLands offer. Okay, right now we're seeing the model in 3D and the plants are in realistic display mode, but just notice that from here we can switch from the elevations to conceptual, detailed, and realistic again. Okay, also if we are working from the 4 viewports, we can let this button enabled, so all these changes will apply on the 4 viewports. For example, we can switch also to the 2D representation, so all the viewports will switch into the, but we can also assign these display modes individually by viewport. So if we click on this button, now we will be able to set, for example, from the left view, the elevations. From the top viewport, we want to work in 2D, so we'll select this 2D representation, and from the perspective view, we'll work in this realistic mode. Okay. By the way, now we're seeing the plants in realistic display mode, and this is the fine level of detail that is kind of suitable for working and seeing a nice view of the project. But these plants will be replaced by a more accurate and more realistic plant when we shot the render. Okay, and also these plants offer different levels of detail even in this viewport. So if we select the plants from this list, okay, we can see here the different display modes that these plants offer, from the conceptual, the detailed, and the realistic, or the 2D crown. So we can click on this button to change the 2D crown into by another one that we have in the library. So we can select any of these blocks for the 2D representation of this plant. Okay, and if you have your own representation, you can add it to this folder as a 3DM file, and it will be available for you to represent this plant species in 2D. Okay, these changes affect only the document, but it can be also applied to the plant database. Now let's insert a plant. Okay, so I'm gonna, for example, insert a plant in that area. So I'm gonna run the plant command. So here in this dialog, we can see the list of all the species that we have already selected. Okay, there are a few of them, but we can just click on the browse button to search for another one. So we can just type here the species that we want to insert. Okay, and the plant database will show you the number of species that match with this criteria. So we can just click on these options to find one specific species that match this criteria, or clear this to start from scratch. And also this plant database shows plants grouped in different lists. So we are seeing the plants that come with render. That means that some plant species have a specific realistic representation developed for that species, but not others, not all of them have. But we can see plants that are suitable for vertical gardens, or we can just see plants that have it added as favorites. So we can click on this here to make your own favorite list of plants, or just show them all. Okay, and we'll see here all the amount of species that are available. Also, we are able here to duplicate an existing species. We could click on this button to copy it and generate a new species that maybe is missing in the plant database based on the copy of an existing one. Or we can maybe click on this button to add a new species from scratch. So we will fill here all this template, okay, with all the morphology and characteristics. Or here we would select also 2D crown, a 3D block for the conceptual shape, another for the detailed shape. Or here we could assign also one of the realistic files that are available for all the plant species. You would search here for the most appropriate one, or you can also develop new plant species, new realistic representation for plant species using a plant editor, which is a plugin that is included into the program. Okay, so I'm gonna cancel by now. Just select this lemon tree. And okay, I already inserted it, but I'm gonna say yes. And then we define here the insert options, such as the proximate height or the random natural variation. That means that if we insert several units, all of them will have slight differences in rotation and size, and will give us the feeling that they are one different to another. Click OK, and we just need to insert that plant in the model. Okay, or we can insert as many units as we want. Here from the right side, we can edit in situ the dimensions of these plants, the properties of these plants. Okay, but we can do it afterwards. So when we end the insertion of these plants, we can select any of them, and from the edit panel, we will be able to edit the plant, change another species, okay, and do anything that we could do when we inserted it. Let's move on. Let's insert a terrain here. So this is a common situation where we may have 2D curves that were existing in the DWG file, or we got from a new DWG file. The terrains in RhinoLands are created from points and curves, but they need to be in their proper elevation. That means that if, like in this case, they are all on the same plane, we'll need to elevate them first, okay? I'm going to work in different display mode, for example, the wireframe. And from the terrain tab, I'm going to use this command, elevate curves, that will show this dialog. And we basically need to draw a line that intersects with all the curves that we want to elevate. Okay, so we need to define an increment, for example, 1 meter. And when we click on the apply button, you'll notice that these curves are elevated according to this increment. Okay, we close this dialog and we'll see that now we have the curves in the proper elevation, considering that these curves were representing contour lines every 1 meter. Okay, but just consider that the curves or points used for creating terrains can have any 3D, can be in any position in the 3D modeling space. For example, we can select this control point and raise it, okay, and still create a terrain with this curve. Okay, so let's do it. I'm gonna run the terrain command, select all these curves, okay, maybe also points, okay, and hit enter. Right, so we have here the insert option, so we need to define a cell size for the resulting terrain. The smaller this cell size is, the more accurate it will be with the input data geometry that are those curves that we have just selected. And we have the option here to enable a base or not, and define the height of the base. And also here we can assign a material by default. There is a library of materials available that we can select. But of course, if you have any other texture or material, it's up to you to select your own one. And here under the contour lines, we can define the contour interval. Okay, this is calculated automatically, but we can define any other value. All right, let's say OK. So we can see the terrain created. All right, let's switch back to the rendered mode, see how this looks like in rendered. And well, now if we select the terrain, we can see that it has integrated some of the control points, well, actually all the control points of the curves that was used to generate it. For example, we can select this control point from that curve and maybe play with it to change the topography of this terrain, right? Okay, and well, if we select the terrain, if we go to the input data tab, we can see here the list of all the geometry, all the curves, including the control points that were used to generate it. So we can select any of these contour lines and remove it, so the terrain will be regenerated. Okay. And now, as we insert new operations, we'll see how they are displayed in this input data tab, and let us modify these operations. Okay. All right. So the first thing I'm going to do, since I see that this area is overlapping with an existing surface or zone that I had underneath, so I'm just going to trim the terrain from an existing curve. I'm going to switch back to wireframe a second, because here I have a boundary curve that was previously created, but I'm going to use it to trim the terrain and define the new boundary for the terrain. So here I've got a command that will let me do that. So I need to select the terrain. Just notice that here from the command line, whenever you run a command, you just need to follow the instructions indicated here. So it's pretty user-friendly to run any command with any previous experience. Okay, we just need to just follow the steps. So I'm gonna pick the terrain, hit enter. Now it asks me to pick a closed curve. So I'm gonna select this curve, and we are done. Let's see this back in rendered display mode, how this looks like. Okay. Now if we activate the 2D representation of the model, the terrain is displayed with control curves every 50 half meter. Okay. And here I have an overlapping of the original curves, so they were stored in layers, in a specific layer. So I'm gonna hide that layer. I think they were in that topography layer. There we go. And I'm gonna show this back in 3D. And I mean, the terrain has an option here. If we select it, and we go to the general tab to show the both 2D and 3D representation. So it's quite kind of nice to see also the contour lines overlapping the 3D geometry. Okay. Now let's add some operation in this terrain. For example, we can add a cut and fill operation, I'm going to enable here some curves that I have for that purpose. Maybe I'm gonna see. I mean, I'm always changing the display mode from here, but I remind you that you can do it easily from here if it's easier for you. Okay, so okay, I think I've got that curve over here. Yeah. So I'm gonna create a cut and fill based on this rectangle. So I'm gonna move this a little bit up. So I want that this curve intersects a little bit with the terrain. Okay. So when we add a cut and fill, it cuts some part of the existing terrain, but also adds some volume in order to flatten the terrain on that curve. So we go to terrain tab, and now I'm gonna use this cut and fill command. So we'll pick the terrain, enter. I need to define a slope within the interval of 0 to 90 degrees, basically how the terrain will meet with this boundary, okay, the slope around this boundary, let's say 45 degrees. And finally, I select this closed curve. Okay, hit enter, and we're done with this cut and fill. Now, if we select the terrain, we have here this extension arrow, this double arrow that lets us change the elevation of this cut and fill. Or we can just get at some of the grip points, and just move it to any other position to change the boundary of this cut and fill. Okay. All right. Maybe we can also add a path here. We have here a curve that now it's on the 0 elevation. So I'm gonna elevate it first to the terrain. So there is an option at the edit panel to adjust a curve to the existing terrain. So we will select it, go to adjust, and select two terrains. And now that curve is approximately on the right position, so we can add a path on that terrain based on this curve. If you want to have this path on a specific slope, you need to elevate it first with the desired inclination, and then apply the path command on it afterwards. Okay. But again, the position of this curve and their control points will determine, the slope of this path on the terrain. So let's do it. Let's run the path command here. I'm going to select the terrain. Now select the width, let's say 3 meters in this case, and pick an angle for the slope within the interval. In this case, we'll say 30 degrees. So finally, just need to select that path axis, and the path is that. All right. And again, if we select now this terrain, the control points of the path axis have been integrated into terrain, so we can change that endpoint to another elevation or to another position. Okay. All these operations that we are doing can be listed. Okay, can be listed and will be linked with the terrain. So if we go to the documentation tools, we have here the option to add a terrain list. So we just select an insert point, and this will list the amount of land that has been necessary for the fields and the paths of these operations on the terrain. Okay. And again, if we select the terrain and we go to the input data, we can select, for example, the path and change the width to, let's say, 4 meters. So the path will be recalculated, but also the values for the fill volume and dig volume for that path operation. Okay, so this is a list that is connected live with the 3D model. And also for other kind of lists. So we insert here a plant list. We can see here all the species in our project. Okay, there are some other features that we can add to this list. For example, if we select it, we can go here to the list parameters and maybe add the density. If we are using ground covers, for example, we can add the initials. Okay, we can even add custom parameters. All right. So you can customize all this list as you wish, or finally you can export it if you like. Okay, there are some other parameters here to edit the appearance of this list, so I let you play with them and discover them. And but the idea is that this list is connected with the 3D model. For example, let's insert here a new forest. Okay, I'm gonna work from the top viewport, and I'm gonna run the forest command. In this case, I'm gonna select an existing species, for example, the jacarandas, or maybe the Abies alba. Okay, again, I select the initial height. I will make sure I have the natural variation option, so the plants look a little bit different. And from the forest tab, I'm gonna select the settings of this forest. So let's say that I want 60 units and a minimum distance between units of 3 meters. Okay, or we could distribute them in a regular array according to different parameters. But let's try this option first. And now we have different options to create this forest. So we can either pick an existing curve, or we can draw it on the fly, picking any of these options. So I'm gonna select the polyline option and start drawing the boundary of that forest. Okay, you don't need to close this boundary. If you do right click, it's gonna close it automatically. And then, and now we can select this forest. We can select it and redistribute it. Okay, we have here all the options. We can maybe combine different elements, so have 2 different species in our forest, and from that part of the edit panel we can select one and change maybe the species. Okay, so we're combining a species in our forest, so we can edit this forest at any time. Okay, and if we see that from the 3D, you will see that all the plants have been already projected on top of the terrain automatically. Okay. Also, there is an interesting option to clear plants from a specific area. So if we select these plants, here we go to forest and add whole. So if we select that rectangle, we will ensure that no plant is located within this area, no matter which is the distribution of this forest. So it will keep clear the plants from that rectangle. Okay. And of course, now we can see that the plant list has updated. So we have many new units with for the Abies alba and many new ones for the jacarandas. Okay. Okay, let's see some of the civil work tools. I would like to show one of the new commands that we have included in this new version of the program, which is the ramp object. It's a very useful command that can be created from splines, from run through different flights. I'm gonna draw it from the top viewport, and I'm gonna create a ramp in that part. So you run the ramp command. You have here the insert options, for example, which is the hard start height. Okay, and if we go to the flight tab, we can define the height of the ramp. Okay, this is defined by a number, or can be also defined by a percentage, okay, of the slope, or a proportion between the rise and the run. In this case, I'm going to select height. I'm going to define this 40 meters is fine, and click OK. So I'm going to draw it as a polyline in this case, and I'm going to snap here. I mean, I need to make sure that I have the justification to the left. Okay, and the width will be maybe 1 meter only. And now I can insert that ramp in here. All right, so let's go to the perspective, see how this ramp looks like. Okay, and we can select it now and well, change the width, maybe make it a bit wider. Okay, now we can select these stairs, also change its width. So all the objects we have here are parametric, so we can edit them easily. Okay, and this ramp from the 2D is displayed with a specific well, annotation indicating the slope. Okay. Maybe we can insert also some elements here. since we have this curve for the path, we can insert a row of elements. So I can show you how this command works. Basically, it distributes objects along a curve, and these objects can be selected from the block library that RhinoLands provides. So we have here a list of well, 3D blocks from lighting, fountains, stones. Okay, you can find many blocks. Take into account that you can select any block that you find on the web as long as it supports. It's supported by RhinoLands. So this includes blocks available for SketchUp, for 3D Max. Well, of course, Rhino blocks. So you have the option here to include the blocks that you find on the web into your project, okay, and make it work with these options. But I'm going to select maybe one of these lighting elements, maybe this one, and well, you just define here the features of that element from the row. So I'm going to set the separation to maybe 8 meters, for example. I wanted to define some distance to the axis because I don't want the lights to be placed exactly on the middle of the path. So I'm going to define a distance of 2 meters and then click OK, select that curve. And we can see here the row of elements. Okay, so we can just select them and change the properties, maybe change the distance to axis to a bigger value, okay, or make the separation a little bit more. Okay, let's move on. Regarding the documentation tools, some of the first things that you may want to do in a project is defining the areas, right? When we are working on the top viewport and we're using this 2D representation of the objects, maybe it's nice to insert the zones of the project so we have an idea of how the areas in our project will be distributed. In this document, we have already created a few zones, such as this one or this other one, but we can insert new ones. So I'm going to do it on that part of the project. Go to the documentation toolbar, select this zonify command, and basically we'll need to pick a boundary curve or pick inside an inner point inside a region that will be detected by RhinoLands to define a new zone. Okay, the zones are generated as 2D hatch pattern, as hatch patterns in 2D, and also as a textured surface in 3D. So here I can select a different texture from the library. So we need to define here an area. Let's call this building, imagining that there is a building in that part, and well, define here the features of the zone. I'm gonna select a different pattern, okay, and click OK, and finally select the insert point for the level. Okay, and now we can insert a zoning list. So we will see also the new zone that we have generated. If we select this zone, maybe we can display also the icons so we can identify them easily. And maybe we can see some other commands. For example, we have here, of course, all the tools to dimension this project. Okay, but yeah, we can also add labels, plan photos, slopes. For example, we can see the slope of this path on the terrain just selecting that curve. Okay. So the slope basically will project the start and end points on the terrain and will calculate the slope. Okay. So finally, let's maybe just to finish, show how to create an animation for this project. So I'm gonna enable the animation panel. By default, it's available here in this part of the dialog, but you can always open it from this list of most useful panels. Okay, so we can find the animation panel here, and we can just drag this panel at any part of the interface, but if we drag it next to the other, it will be docked in that part. Okay. I'm gonna enable also a curve that I have in a specific layer, camera path. So, and I'm gonna use this curve as the camera path to create the animation. So I'm gonna move to the animation tab, select this button to assign a curve to the camera path. So I'm gonna select this curve. And once it's selected, maybe I can just hide it. Okay, I don't want the curve to appear in my recording. And here I need to define the animation name, if it's working from using frames per second or a total duration of specific seconds. And also you can define here if you want to record it using the Rhino's display, which is the rendered in this case, or if you want to save it to a specific folder. Also, if you choose the Rhino render or V-Ray or any render engine that you are using in this session, well, will be the one that applies here. Okay. If we just use a display, we will be able to see a quick view of that animation. So we just play it and see how this animation looks like. All right. Also, there is an interesting option to navigate through the project, which is the walk mode. You can find it under the visualization tab. You click on the walk mode, and this will put you on the ground. So with the cursor of the mouse, you just need to point to the desired direction, and it will detect the terrain. With the mouse wheel, you can increase the speed of a walk, and it's an interesting option to navigate through the project interactively. All right. And well, also if you want to show some, present the project, the plans of the project, we can work from the page layout. Okay, here we got already a few details. Okay, details are the viewports to the model space. I mean, so we can add, I guess this is, yeah, this is a detail. So this is actually a viewport to our model. Okay, so we can have one detail for the top viewport. Here I can go to the edit panel and show this view in 2D. Okay, maybe I'm gonna show the wireframe inside this view. While in this other detail, I'm showing the 3D view. Maybe in this detail also can show yeah, an elevation or a section of that view, or I can select the elevations. Okay, and maybe we can insert here another detail to see maybe all the list. Okay, so we go to the documentation. I will add a new detail. And then I just need to double click inside it and just zoom in one of these planting lists, for example, to display this list in that layout. Okay, of course, here we can add many other details such as title blocks, text, images, okay, for defining the details of the project. And we will have the project ready to be presented. Okay, so that's it, an overview of RhinoLands. So I hope you have enjoyed, and I will be very happy to help you with any questions or doubts you may have. So feel free to ask. Thank you.